Welcome to the U.S. Military Test Prep channel by Study.com. My name is Eric, Marine Corps veteran, and I'm an ASVAB test prep expert. In today's video, we'll practice applying number properties involving multiples and factors, such as using the least common multiple, greatest common factor, or distributive property to rewrite numeric expressions. This will help you prepare for the Arithmetic Reasoning exam, which is one of the subject-specific sections of the ASVAB. Let's take a look at our first problem. What is the least common multiple of 8, 12, and 18? Is it 24, 36, 72, or 96? Well, let's start by defining what is a multiple. A multiple is basically the product result of multiplying two numbers. So if we wanted to find multiples of, let's take an easy number. Let's say if we wanted to find multiples of the number 5, then we would take, 5 times 1 equals 5, and then 5 times 2 equals 10. 5 times 3 equals 15, and on and on and on. And so everything that you could multiply by 5 and get a product, those are all multiples of the number 5. So the least common multiple means that if we were to make that list of multiples for each of the numbers provided here, 8, 12, and 18, what is the smallest multiple that they would end up all three having in common? So we're going to do this by finding the prime factors of each of these numbers. So we have 8, 12, and 18. So we'll start with 8, and let's think about what the prime factors are. So we'll come over to the side here, and we'll start with the number 8. And a quick, easy way to do this, I like to kind of think of what is an easy number to multiply this by. And because it's an even number, I like to start with the number 2. It's just an easy one, and then I know I've got a 4 here, and then if I break that down, well, 4 is even also, so I can divide that by 2. That's 2 times 2, and that's about as small as I can get. So when I come back over here, it's 2 times 2 times 2, 2 cubed. So now let's look at 12. If we come over here and do the same thing with our 12, then again, it's an even number, so I like to start with 2. That's just an easy one. And we're down to 6. We get 2 and 3. So now we're down to the prime factors here. That's as small as we can go. So now we've got a 2 times 2 times 3, which is the same as saying 2 squared times 3. That's our prime factorization. So let's come over here and do 18 now. It's an even number again, so that's 2 times 9 gives us 18. Then if I break that down further, I've got 3 times 3 gives us 9. So now that's 2 times 3 times 3, or 2 times 3 squared. Now we've got our prime factors. So here's the trick. To get the least common multiple of numbers, we can easily find that by taking the highest powers of all the prime factors. So in this case, what we have is 2 to the third. That's the highest power there. And then on the 3 here, we've got 3 squared. So if we took 2 to the third power times 3 squared, 2 times 2 is 4, times 2 again is 8, times, and then 3 times 3 is 9. That equals 72. So that's our answer. A school is organizing students into equal groups for a field trip. There are 84 boys and 108 girls. What is the largest possible number of groups that can be formed with each group having the same number of boys and girls? Is it 6, 12, 18, or 24? So we've got 84 boys and 108 girls. And we're going to do this problem by finding the prime factorization. So we'll do our little trick here. Because it's an even number, 2 is an easy one to start with. So that gives us 42. And then I can go 2 again because it's even. That'll get me down to 21. And then this would be 3 times 7. Now we're down to all prime numbers here. So we've got 2 times 2 times 3 times 7. Or 2 squared times 3 times 7. Now if we do the same thing for our 108 girls, it's an even number again, so we'll start with 2. That's nice and easy. Get 54, even number, so we'll go to 2 again. That's 27. And then we can go 3 times 9, and then 3 times 3. So that gives us 2 times 2 times 3 times 3 times 3, or 2 squared times 3 to the third power. So if I took these and I tried to kind of break these down to something simpler, so let's rewrite them. 2 squared, and then for the 108, I've got 2 squared, so that's the same. And then I can go times 3. Well, I can pull one of these 3's out, so I can do times 3. times 3 squared times 7. So now I've broken this down as far as I can get it where I can keep two things in common here. And then I've got a 7 here, and 3 squared is 9. And so those kind of stand alone. So if I work this out a little bit further, then I've got 2 times 2 is 4 times 3 is 12. So I've got 12 times 7 equals 84. And then 2 squared times 3 again is 12 times 9 equals 108. So this 12 is our greatest common factor. And so that's our answer. That's the most groups we can form and keep them equal. Which of the following expressions is equivalent to 84 plus 126 using the distributive property? And you can see in our answer set, it looks like some fairly simple factored expressions. So what we're going to do is we're going to find the prime factors, and we're going to see what we can find in common here. Since we know that the expression we need to end up with must be equivalent to 84 plus 126, there are no variables in there. We have all the information. And then in our answer set, we've got all the information as well. So there might be a simpler way to do this. We could start with our answer sets and just work them out. So let's start with this top one. We have, 6 times 12 is 72. Well, right off the bat, we know that's not going to work because neither of these numbers is 72. So there's no way that could work. And then we have 7 times 10. Well, that's 70. And that doesn't add up to either of our answer choices either. But then we've got 14 times 6. Well, that's 84. So that's looking promising. Plus 14 times 9, and that's 126. So that looks like what we're looking for, but let's just check D just to make sure. 21 times 3 is going to give us 63. So it looks to me like C is the only one that really fits. So that's our answer. Great job. The sum of the two numbers is 72, and their greatest common factor is 12. Which of the following could be the two numbers? When we read this carefully, it says, which of the following could be the two numbers? That's an indicator that there might be more than one right answer to the problem. And so what we're looking for is, within the answer sets provided, which one fits. So there are two parts to the question. The first one is, the sum of the two numbers is 72. So that's a quick check. We might be able to eliminate some answers there. So let's just check through that real quick. So 12 plus 60, that equals 72. So that one could fit the first part. 18 plus 54, yep, again, that's 72. So we're good to go there. 24 plus 48, yep, again, 72. And 30 plus 42, yep, once again, 72. So we know that they all pass the first check. So it's all going to come down to this second check. We're looking for the greatest common factor of 12. So let's find our factors real quick. That's 2, 3, and 7. So we have the 2 and the 3, 2 times 3, in common on both sides. So that's going to be 6. So the greatest common factor here is 6. So that does not pass the second test. All right, let's try this next one now. So 48, we get 2 times 2 times 2 times 2 times 3. So 2 times 2 times 2 times 3, we can find on both sides here. So that means that our greatest common factor for this set of numbers is actually 24. So C would fail the second test. All right, let's keep moving on. And then 54, even number, gives us 2 times 27, 3 times 9, 3 times 3. So 54 factors out to 2 times 3 times 3 times 3. And we can see we've got that whole first section in common there. So that makes our greatest common factor 18. So once again, B fails the second test. So by simple process of elimination here, I think we know where we're headed with the answer. I think A is probably our answer, but let's work it out just to validate that we've understood this correctly. So for 12, we've got 2 times 2 times 3, and then for 60, we've got 2 times 2 times 3 times 5. So all of this is in common. That's our greatest common factor. So our greatest common factor is in fact 12, and that passes the second test. So that is our answer. Okay, that's the rundown on applying number properties involving multiples and factors, such as using the least common multiple, greatest common factor, or distributive property to rewrite numeric expressions. If this video helped you out, give it a thumbs up. Drop a comment with any questions or topics you want us to cover in the future, and don't forget to subscribe for more U.S. military test prep content. I'll see you in the next video. You've got this.